the planet on which we live, is the home of almost 3 billion human beings. Scientists have traced the record of mankind on this planet back about 2 million years. But this Earth of ours and the other planets of the solar system are much older than 2 million years. How did the Earth and solar system come into being? One theory is that several billion years ago, the universe consisted of many masses of cosmic gases and dust. One of these masses became our solar system. Due to gravity, the matter in this mass began to collect and rotate. Pressure and temperature grew higher and higher until the mass burst into white-hot brilliance. Through millions of years, the white-hot matter whirled. The nucleus, or central portion, coalesced, and great spiral arms of dust and gases were left behind. The material in these arms rotated around the nucleus. At the same time, gravity caused the particles in these smaller masses to group together. Scientists believe that the extremely hot nucleus became the sun, while the other groupings of matter became the planets. The matter that became Earth was in a state of white-hot heat, probably because of radioactivity. For several billion years, the Earth remained white-hot. Then, gradually, it began to cool and give off a variety of gases which were to become our atmosphere. Sometime during the Earth's cooling process, storm clouds, similar to those we know, developed. These storm clouds produced great torrents of rain which speeded the cooling process. But much of the Earth was still molten. As centuries passed, however, these materials slowly lost their heat. In some places, great masses of rock were formed, where lighter matter floated to the surface, cooled, and solidified. The building up of rock mounds in certain areas left huge depressions in others. These depressions were gradually filled by the waters of the great rains. Thus were formed the major surface features of our planet: large bodies of water and great land masses. Evidence about the Earth's interior is gathered in many ways. Some of this information indicates that the heat of the Earth increases about 16 degrees Fahrenheit with each 1,000 feet below the surface. If this increase were constant, then at a depth of about 160,000 feet, approximately 30 miles, the melting point of rocks would be reached. However, enormous pressures at this depth keep the rock in a semi-solid state. This means that our Earth is simply a thin crust of rock on top of a semi-solid interior, much as this sheet of mottled paraffin floats on top of the water in this tank. Scientists, called seismologists, have given us other reasons for believing this theory. Much of their work is done with machines like this, called seismographs. Through work with the seismograph, scientists have established this picture of the Earth in cross-section. Generally, there are 3 main regions: the outer region, or crust, about 20 miles deep and consisting of solidified rock; the mantle of 2 layers, continuing to 1,800 miles deep and consisting of semi-solid rock; and the core. Scientists are fairly certain that the core consists of heavy metals such as iron and nickel in an almost molten state under great pressure. Why heavy metals? This simple demonstration may show us. In this beaker of oil are 2 materials of different weight. We stir the mixture. This represents the Earth in a molten state. The heavier materials, such as iron filings, settle out first. They are followed by the somewhat lighter materials, such as sand. It is believed that in much the same way, the heavier molten metals were drawn to the core of the Earth by gravity. Though much of our knowledge about the core and mantle is based on theories, we do have specific information about the crust of the Earth. We know about the mineral elements of the crust and how the crust has been modified into various landforms. And we know that landforms are made up of 3 kinds of rock. Here are samples of the 3 kinds of rock found in the Earth's crust: igneous, sedimentary, and metamorphic. At first, all rocks on Earth were igneous. Common igneous rocks are granite and basalt. Igneous rocks, such as this cliff of granite or this one of basalt, are formed by the cooling of molten rock. Igneous rock is a basis for sedimentary rocks such as sandstone and limestone. Limestone and other sedimentary rocks are made up of small particles of rock which have become cemented together under extreme pressure. Like sedimentary rocks, metamorphic rocks may be formed from igneous rock. Among the more common metamorphic rocks are marble, gneiss, and quartzite. Metamorphic rocks, such as quartzite, were once igneous or sedimentary rocks, but they have been changed by heat or pressure. These 3 kinds of rock, then, metamorphic, sedimentary, and igneous, make up the Earth's crust. Mountains and mountainous lands are often composed of granite and igneous rock, that is, molten rock that cooled and solidified. Some mountains, called volcanoes, are also solidified igneous rock. This rock has been built up by the action of volcano. Sometimes pressure on this molten rock builds up and the liquid rock is forced or squirted into an opening or fissure and comes to the surface. In time, this molten rock will solidify to become igneous rock. Running water is chief among the natural forces that attack igneous as well as other rocks. Water tends to wear away particles of these rocks and carry the particles away. These particles tend to settle out of the water, as we see in this sandbar. If this material were subjected to intense pressure, it would become sedimentary rock. In the Grand Canyon is a vast collection of sedimentary rocks. These rocks have been exposed by waters of the Colorado River as it cut deeper and deeper into its canyon. Each of the sedimentary rock layers of the canyon represents an accumulation of billions of fine particles of rocks which settled out of the water. Some sediments were deposited by wind rather than water and became sedimentary rock. We know that certain forces within the earth, such as heat and pressure, can change sedimentary and igneous rock. Marble, for example, is a metamorphic rock. Long ago, sedimentary rock was changed by heat and pressure into this marble. Across this great home of ours, the earth, the land, and the floors of the oceans are composed of one or more of the 3 kinds of rock. Scientists, using specialized equipment, have given us theories about the interior of the earth and its structure. Other scientists have given us theories attempting to explain the formation of the earth and the great changes that have taken place in its long history. Scientists are continuing their work today, mapping the surface of the earth, its oceans and continents, and exploring and gathering information about what lies below the relatively thin crust of our planet. Through their work, we may, in future years, know more about our Earth and its structure.